Look at this plant. Yellowing leaves, stunted growth, textbook nitrogen deficiency. Now, look up. The air around you right now is 78% nitrogen. It is literally the most abundant chemical in the Earth's atmosphere. There is more nitrogen floating above this one plant than it could ever use in its entire life. And yet, it's starving. Today, we're going to follow nitrogen on its whole journey from the atmospheric gas all the way into your plant. And along the way, I'm going to let you in on something that the fertilizer industry doesn't really want you to talk about. Nitrogen isn't the whole story. Not even close. Before we go deep, let's look at the whole map. Nitrogen is constantly moving between forms. Think of it like a currency exchange. Atmospheric nitrogen is like gold bars. It's valuable, but you can't exactly spend it at the grocery store. It has to be converted into something usable first. That conversion happens in the soil. And here's the part that always blows people's minds. It's run entirely by biology, not fertilizer, not chemistry, living organisms in your soil. The cycle goes like this. Nitrogen gets pulled from the atmosphere and fixed into the soil. Soil life breaks down organic matter and releases it in forms plants can actually absorb. And if conditions go wrong, like waterlogging or compaction, that nitrogen gets sent right back into the atmosphere as a gas. Just wasted. So let's walk through it. Here's the basic problem. Atmospheric nitrogen is two atoms locked together in an incredibly tight bond. It takes enormous energy to break it. Plants can't do it, and animals can't do it either. The only thing that can crack the bond are specialized bacteria living in the soil. They carry a special enzyme, basically nature's only nitrogen cracker. And without them, the whole system just falls apart. So right from the start, nitrogen availability is a biology problem, not a chemistry problem, which matters a lot when we get to how you feed your soil. There are bacteria in the soil that can pull nitrogen straight out of the air and deposit it into the ground. Some do it solo, but the real powerhouse is the partnership between certain bacteria called rhizobia and legumes. Do you see these little bumps on the root? Root nodules. Each one is basically a nitrogen factory. The plant provides the bacteria with energy from photosynthesis. The bacteria, they pay their rent by fixing atmospheric nitrogen directly for the plant. It's a partnership that's been running for tens of millions of years. So here's a quick trick. Cut one of those nodules open. Pink or red inside means that it's actively fixing nitrogen. White or pale means that it's not really working. That's a fast, free soil diagnostic most gardeners never know about. This is the reason that farmers have rotated legumes, clover, beans, vetch, into fields forever. Planting a cover crop of legumes isn't just about ground cover. You're literally pulling nitrogen from thin air and banking it into the soil. Most of the nitrogen already in your soil, it's locked up in organic matter. Dead plant matter, old roots, decomposing leaves. It's there, but plants can't access it yet. It has to be unlocked by soil organisms, which break it down and release it in a simpler form plants can drink up through their roots. This is called mineralization, and it's happening constantly in healthy soil. Here's something worth knowing. The ratio of carbon to nitrogen in what you add to your soil matters. High carbon materials like wood chips or straw take a long time to break down. And during that process, soil microbes will actually pull nitrogen away from your plants that have been dug in temporarily while they do their work. It's not permanent, but timing matters. Fresh grass clippings, vegetable scraps, and young green cover crops have a much lower carbon to nitrogen ratio. So they break down faster and release nitrogen more quickly. Understanding this is more useful than almost anything you'd read on a fertilizer label. Once nitrogen is released from organic matter, it goes through a couple more conversions before your plants can fully use it, handled again by soil bacteria. The catch is that these bacteria need oxygen to do their job. Compact your soil, waterlog your beds, stop air from moving through, and that whole conversion process grinds to a halt. And if conditions get bad enough, a different set of bacteria takes over and actually runs the process in reverse, converting usable nitrogen back into a gas that escapes into the air. All that work, all that organic matter, and the nitrogen, it just evaporates. This is why soil structure matters so much. Loose, aerated, well-draining soil keeps nitrogen in the system where plants can use it. Compacted, waterlogged soil bleeds it out constantly in the background without you ever noticing. Drainage and aeration, they're not just about root health. They're about keeping your nitrogen from disappearing. Oh hey, if what I'm saying is resonating with you, then the best way to support this channel is to grab a Soil Nerd t-shirt just like this one. I will leave a link in the description below. So how do you actually get more nitrogen into the ground without reaching for a bag of synthetic fertilizer? Well, the good news is there are a lot of ways, and most of them are improving your soil at the same time, not just juicing it temporarily. Compost is the workhorse. Good finished compost releases nitrogen slowly and steadily as soil organisms continue breaking it down. It also feeds the microbial community that runs the whole nitrogen cycle. You're not just adding a nutrient, you're building the system that manages nutrients. There's a big difference. Cover cropping with legumes, we're talking about clover, winter rye, mixed with some vetch and cowpeas, those let you fix atmospheric nitrogen for free over a season. Cut them and leave the roots in the ground before they go to seed, and that nitrogen goes straight into your soil. Grass clippings applied as a mulch or gently worked into your beds break down quickly and release nitrogen fast. It's free and most people are just throwing them away anyway. Coffee grounds are another one. They have moderate nitrogen content and they feed soil organisms well. Use them gently mixed into your topsoil rather than just piled up into one section. Aged manure like chicken, rabbit, cow, horse, they are a classic for a good reason. Chicken manure in particular is high in nitrogen, but you want to let it age or compost first so it doesn't burn the roots. Too much nitrogen can burn your plant roots. The common thread through all of these is that they feed the soil, not just the plant. That is a fundamentally different approach than a liquid nitrogen fertilizer that bypasses the whole system. Now here's what I really want you to take away from this video. Nitrogen gets talked about constantly. It's the N in NPK, and it's on every fertilizer label. And yes, plants absolutely need it. Deficiency looks dramatic. It's easy to diagnose, which makes it easy to sell a solution for. But the way nitrogen gets marketed, you think that it would be the whole game. It isn't. Plants need around 17 essential nutrients to thrive. Phosphorus for root development and energy, potassium for disease resistance and water regulation, calcium for cell structure, magnesium, that's the center atom of every chlorophyll molecule, sulfur, iron, manganese, zinc, boron, it goes on and on. And here's the thing about nutrients, they interact. Soil that's overloaded with nitrogen can actually interfere with calcium and potassium uptake. Lush, fast-growing nitrogen push plants often have weaker cell walls and are more attractive to pests. There's real research on this. More isn't always better. Healthy soil is balanced soil. The goal isn't to max out just one number on a bag. It's to build an environment where the full range of nutrients is cycling, is available, and being managed by a living system. Which is exactly what good organic matter inputs and a healthy soil food web do. They don't just add nitrogen, they support the whole thing. So back to that struggling plant. It wasn't failing because there was no nitrogen nearby. It was failing because the system wasn't working. Bad soil structure, depleted organic matter, a microbial community running on fumes. Nitrogen is part of the story, but it's only one part. Building healthy soil, real, living, balanced soil, and the nitrogen cycle, along with a dozen other cycles, starts running on its own. And that is the goal. If you want to go deeper into the full picture of what's living in your soil and how it all connects, I've got more videos on that below. And if this reframed how you think about fertilizer even just a little bit, share it with a gardener who really needs to hear it. I'm Sunny. This is Sunnyside Soil. So go feed your soil.